Let's say that we have this simple program. This program is fine, but a bit cumbersome. As you might see, we represent here two children, and both of them have the same attributes. Yet, we have to define these attributes twice, once for each child. It could be convenient if we could somehow create a pattern of a child, sort of a blueprint that can serve as a guideline when defining a new child. So it turns out that this kind of need comes up a lot in programming generally and specifically in Python. That's why there is a way to create such a pattern, and it's called a class. And classes stand in the heart of object-oriented programming. So in our case, we could create a class for a child. So what we did here is define the structure of a child. Notice that in the code of the class, we don't have the details of any specific child, only the attributes that we expect every child to have. So the things you see here after self dot, so this one and this one and this one, also this one, these are the attributes that we define for the class. So instead of defining the attributes twice, both here and then here again, we only define the attributes once over here. So whatever we have after a self dot is an attribute of the class. And we can see that we assign values to these attributes according to some arguments. We will get back to these arguments. Now I want you to notice that we have a function inside our class. That's the init function. By the way, a function that's inside a class can also be called a method. So we have the init method. As we'll see later, we can have many methods in a class, as many as we need. But the init method is special. It's going to run whenever we use the class to create a new child. And here comes the part that confuses many people. The class itself does not have any concrete data. It has no specific details. It's nothing but a pattern, a template that we use to create actual children. If we want to have a specific child, we have to create an object of this class. So classes are the general structure, the template, and objects are concrete beings, a specific instance of the template. So how do we create an object of the child class? We simply write the name of the class followed by parentheses. Now, since we have a list of arguments in our init method, we have to provide values for them when we create the object. For reasons we'll get into later, we don't have to provide a value for the first argument, self, so we're going to ignore it. We do have to provide values for the rest of the arguments. And now, child1 is a new variable holding the value of an object of the child class. And I think that most people would agree that as opposed to what we had here, this way of writing creates a very clear boundary between the template, what we want every child to have, and a specific instance, the attributes of this individual child. Moreover, if we now want to create another child that's based on the same template, it's really easy to do. So now we have two distinct children, and both of them are based on the child class. To access any field of an object, write the name of the object followed by a dot, and then the name of the field. And here we can see the output. Notice that while we could use any of the objects to access the first name field, using the name of the class itself followed by the field will not work. And that's because, as we said, the class is a template and nothing else. It does not have any values by itself. Only the objects that we make out of this class, they have specific values. Classes are not limited to only store values. They can also contain functionality. The idea here is that the purpose of using classes is to have something that represents some being, something that may have its data and may also have its behavior. Let's say, for example, that we want to be able to print the full name of a child. We can, of course, do it outside the class by accessing the first name field and then the last name field. But we can also implement this functionality as part of the class itself. So just like we had the special method init, we can also write methods of our own. And now, just like we access the fields of an object, we can access the methods of an object. Now, two important things to notice here. First, we had to have the self argument as the first argument of the method. This is always going to be the case for methods, which are, as we said, functions inside classes. Second, whenever we access a field of the class in any method of the class, we have to use self dot and then the name of the field. Later on, I'll explain why, but for now, just remember that self is always going to be the first argument for any method, and that we have to use it when accessing any field of the class from within the class. Anyway, now that we have the method, we can easily use it for the other object of the class. And we can see that the same code ran, but since it now ran in the context of the child2 object, self.firstName and self.lastName had the values we set when we created this object, child2.